الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmina.
Okay, assalamu alaikum everyone. Welcome to another session with me. I'm Taha Rehah, expert machine learning trainer at Mambo Geeks, and also machine learning engineer at DPECO, focusing on computer vision applied to health tech. So مرحبا بكم معنا في another session على machine learning والذكاء الآلة as we say. بالنسبة للسيشن تاع اليوم ارتئينا انه نحكيو على الفيرتكس اي اي ولا جوجل كلاود بلاتفورم فيرتكس اي اي اللي هو سيرفيس تحت الجي سي بي. السيرفيس هذايا مشهور nowadays علاش؟ على خاطر there is a trendy term that is like اللي معروف اللي قاعد الناس الكل يحكيو عليه الايامات هذه اللي هو الام ال اوبس ولا machine learning operations. So MLOps nowadays, like every company, every tech community is speaking about MLOps. وتحكي على MLOps. Now we are here to understand what is MLOps or why people are speaking about or talking about MLOps, and we are going to see how Vertex AI, how the service or how Google is building Vertex AI to make MLOps easier for everyone and accessible for everyone. So as an agenda for today ولا كأجندة للحصة اليوم إن شاء الله راح نبدأ بتعريف صغير على what is Vertex AI. Then we are going to talk a little bit about the machine learning workflow from A to Z ولا end-to-end machine learning workflow. Then try to define the MLOps strategy and what is MLOps and how it's being used, etc. Then inshallah we are going to define the services of Vertex AI and try to introduce them, like the dataset service and the model services. Then see a little bit about deployments and predictions, how they are being done in Vertex AI and how they can be done using some other tools, open source or out of the cloud. So خلينا نبدأ. Vertex AI. Vertex AI كدefinition هي platform or a service that is here to support your entire machine learning workflow. So Vertex AI is here to like support the machine learning workflow across like many different model types and varying levels of machine learning expertise. ايش تقصد جوجل بالديفينيشن هذه؟ انه Vertex AI كسيرفيس كان تصنع باش يواكب الموديل نتاع الماشين ليرنينج ولا ديب ليرنينج موديل من ستيب ولا من الفيز نتاع انه يكون just data collection and data preparation until انه الموديل يولي deployable and usable by customers or by clients in real life. So Vertex AI تمشي معك من اول ستيب، اول مرحله لاخر مرحله، و varying levels of machine learning expertise، بما معناه انه even واحد ولا someone that is like just starting as a beginner on machine learning, he can use Vertex AI along with واحد or some persons that they are like experts in machine learning and they are like more familiar with Kubeflow, TFX and MLflow, etc. So they can also use Vertex AI and like يستفدوا من things that Vertex AI is offering. So that's the overall definition of Vertex AI from Google Cloud. But to understand Vertex AI and why we even need Vertex AI, we need to talk about the machine learning workflows. So since we said that Vertex AI is here to support the machine learning workflow of a system. To understand the machine learning workflow, there is a perception that is very common in the area of the data science and machine learning, is that ML products are mostly about machine learning. Like that's machine learning code is taking the biggest part of building any machine learning system, which is, to be honest, not true. because there are a lot of things that we need to take into consideration more than machine learning code, and we are going to see them one by one, then to understand why we need MLOps, because that's the starting point. We need to know that machine learning code is not the only thing that we need to take care about when we are dealing with a machine learning system. So that's the starting point, and then we are going to see why and what's the solution that's coming up with machine learning operations. So basically, to build a machine learning project, there are many phases. We can divide them into 4 phases. The very first phase is the discovery phase. Discovery phase, like many people do neglect this phase or do ignore it, but it's very crucial because we cannot just like have the idea and start implementing directly. We need to discover the idea, define the business, define the use case, and do some data exploration. So because basically machine learning, as I said another time, is not only about machine learning, but it's also about data, and maybe it's more about data than machine learning code. And the discovery phase allows us to go and look after like data, some data that are available online, some data that needs to be collected, do some review of papers, of research papers that they did a similar or close work of your idea or of your use case. And then we can move out to the second phase, which is like the feasibility. Is the development of this model or of this idea is feasible? Like when we say feasible, we are talking about technically, and also like in the matter of time. So how many time I need to take? Is it like is going to take like, is it going to need a lot of expertise? Is it easy? Is it like very hard, etc., etc.? So, and also here in this phase, I'm going to select the algorithm based on the feasibility, and based on if the model is the level of complexity of the idea, if it's easy, medium, or hard, I'm going to select an algorithm. So I'm going to select basically either machine learning or deep learning, or like either machine learning or deep learning or any other like algorithms. Then I can come up and select, sorry, after selecting the algorithm, come up to the development phase. So you can see that before they deep dive into development phase, I need to go over other things like the discovery and the feasibility. And now here it comes the development phase. Here where we are talking about data pipelines, about data engineering, about machine learning engineering, about building the machine learning model, testing it, evaluating it, and then presenting the results to the business team or something like this. So development phase is the third one, not the first one. Then it comes the deployment phase. So after any development, we need to deploy. When we say deployment, it's like to making the model available to the public. And when we say available to the public, it can be available through an API, through a website, through a machine learning, through a mobile application, or any kind of those deployment tools. But just to keep in mind that based on statistics that were done, I think last year, more than 85% of the machine learning projects do not make it into deployment. So you can see that more than 85%, which is like a very huge number of the machine learning projects that they are developed, they did not make it to deployment phase, which is like a very huge problem. This is also a problem that MLOps is here to solve, to reduce this number and to make most projects deployable and easy, like more easy to deploy and to be accessible for everyone. So that now that we understood like some phases of the big phases of the machine learning pipeline, we can shrink it into this like small pipeline, where here like we have the part of data, anything related to data. So here raw data comes, we do data extraction, then data analysis, then data preparation. After it, we can like do the training phase, which is development, also development phase, where we train the model, evaluate it, and validate it. Then there is like the part of the deployment, which is like where I take the trained model and I deploy it to a registry, to a model registry, and then I make it available to a prediction service. So to recap, a machine learning pipeline or machine learning is not only about is not only about machine learning code, but this is the reality. So the perception that everyone is making about machine learning is just like, I just have an idea, I need to start implementing the machine learning code. It's totally wrong. So this is the actual size of machine learning code in any machine learning system. So you can see here that machine learning code is representing a very small box, that blue box on the top down, on the down of the image here, and you can see that many other steps are required or that are taking more efforts and maybe more time than machine learning code. So like here we can give an example as serving infrastructure. So doing or configuring the serving infrastructure using Docker or using containers or using anything like this, Kubernetes, etc. So it's also given pain in the head of the data scientists. So it's something that takes lots of time. Also, monitoring or configuring monitoring tools is also not easy. Doing data collection is taking a huge effort and a huge time to do. So we cannot just like, it's not always that easy to go and Google on Kaggle or on Google datasets, open datasets, and you are going to find your dataset. No, most of the time you are asked to go and collect the data from like sources that they are not available publicly online. Maybe you need to scrap the data. Maybe you need to ask for like domain expertise, etc., etc. So this is taking a lot of things, and in reality, it requires a lot of DevOps. So here, a new term that is showing up. So we were talking about MLOps. Now here you are seeing DevOps. I'm going to make it clear what's the difference between MLOps and DevOps, but let's continue on the problems. So just like to recap a little bit on the problems, the very first problem is that models do not make it into deployment. So that's the very first problem. Second problem is that machine learning code is taking only a small part of building a machine learning based system. The third problem is that like machine learning is all about experimentation. It's all about doing experimentation. In real life, data scientists or machine learning engineer do make a lot of experimentations to give out or to make at least one model that can be reliable and that can give good results. So basically they do hyperparameter fine tuning. So they are changing parameters, like you can see, as you can see here. There is a parameter set A. So with parameter set A, we can have one model, which we call trained model A. But maybe this trained model A is not good for us. So we need to evaluate it and then make something even best than trained model A. So here it comes another set of parameters, which is called here B. So we test the models with those parameters, then we have like a new trained model B. Maybe our approach wasn't good, so still A is better than B, or maybe B is better than A, but in a very slight difference. So we go ahead and then try another experimentation with another parameter set, which is called here C, etc., until we have the best, until we find the best model for us. So those steps or those experimentations are like mostly coding. So here is just like about coding, and we need to keep track or to have like history about those parameters that we did, because sometimes when I like have only, or in real life basically, what machine learning engineers are doing without MLOps is just like they do take the model here, and then they try some parameters. They have trained model A, then they change on the same code, on the same repository, you can say. Then they change the parameter set number B. So there is no tracking option in the development of the model, and this is bad because we are losing the history. And if we want to go back from C to A without using MLOps or without the need of the help of MLOps, we are not going to be able to do this. It's going to be hard. So basically, a lot of Control Z, Control Z, Control Z, which is not good and not feasible. So that's why MLOps is going also to help us to solve this problem. Yeah, so basically the experimentations, as I said, are given like many pain to the data scientists, because they are losing a lot of time, they are losing energy without giving or without showing good results. So productivity is going to be down in this case. Also, without MLOps, something called high interest technical depth is going to be showed. So what we call a technical depth in in machine learning system is the fact of speeding up the process. So just like going into from defining the idea into developing the model, then testing the model, then producing the model and making it available online or publicly. So like if we speed this process without like taking care of details and without like giving attention to technologies that we are using, to methods that we are implementing, etc. Like our only concern is to make the model deployable and to output results. This is bad because this is going to cause technical debt. So like many, it's like a credit card. When you pay with credit card, or when you go to the bank and you try or ask for a credit card, they do show you many credit cards, and each credit card has its own interest level. So the best card mostly has the highest interest. So if you pay with credit card and pay with credit card many times, like the interest is going to be higher and higher. It's the same thing for technical depth. If you go over or you pass over details, pass over technical, and you do not give attention to the technical side, the debt is going to be accumulated on you. Then when you deploy the model and you try to read the use case or the real life use case, you're going to find that there are many errors and there are many things that you didn't pay attention to. So you are going to go back another time, and this is going to cause a lot of waste of time and a lot of waste of money to the company. So that's why MLOps is here also to solve this technical debt problem. So to recap, or as a resume, MLOps is simply as is as simple as the lifecycle management for machine learning. So MLOps equal managing lifecycle of machine learning. We have seen the lifecycle. We have the lifecycle of machine learning, which is this one. So just like going over data preparation, model training, and deployment. And MLOps also is helping you to productionize and standardize ML systems rapidly and reliably. So we have been talking about technical debt and etc. So technical debt is, as we said, that like the fact of discovering errors and discovering things that are not good on your machine learning system. So MLOps can save you time and save you money into production and into deployment. So I mentioned it before, the idea of DevOps, or the term DevOps. So I said that in reality, machine learning requires a lot of DevOps, not a lot of machine learning code, which is true. Why? Because DevOps is the fact of managing the code in web development or in mobile development. So basically, DevOps is considered or is composed with two main parts, CI and CD, continuous integration and continuous development. So continuous integration is the fact of testing and validating codes and components, which is like everyone who builds a new component or adds a new code, it needs to be tested, then merge it to the main branch or to the main code. It's the same thing for MLOps, because in MLOps we do validate and test data. Like in DevOps, they are testing code. Here we are in machine learning, we are testing data, and we are validating data schemas and models. So basically, it's the same thing also. It's CI, so continuous integration for DevOps equal continuous integration for MLOps. Just like the difference is that DevOps is dealing with code, MLOps is dealing with data and models. Second thing is focusing on single software package or service. So DevOps is focusing on only one single software or one single package. But MLOps, it considers the whole machine learning training pipeline. So from data collection to model deployments, which is like something even better. Then like the deployments and moving to the next task, which is like continuous deployment. Here in MLOps, we are not like only deploying and moving to the next, no, but we need to deploy and we need to monitor the model. So which is like continuous training, continuous development, and continuous monitoring. So continuous training for monitoring the training phase and automating the training phase. Then we have continuous deployment for like making the transition from training to deployment easy and feasible. Then there is the transition from DevOps to from deployment to the fact of retraining and resharpening the results. This is called continuous monitoring. So we have continuous training, continuous deployment, and continuous monitoring. Okay, so basically, now that we have, let's take questions before. If there is any question about MLOps before, it was just an introduction. Other sessions are going to be, next sessions are going to be deep dive into MLOps. But now I'm going to switch into Vertex AI and how Vertex AI is solving this in a managed way. We are going to start with the managed way. Then next session we are going to see the the not managed way or the custom way. So any questions? Let me see here. Okay, so people were asking about English. Yeah, sorry. Okay, so basically, if no questions in the next 10 seconds, we're going, as I said, we're going to switch to Vertex AI, which is the managed MLOps tool done by Google or made by Google. You can see here a schema of all the services that Vertex AI is offering. So you can see that we have here like AutoML, which is like the biggest part. AutoML is like doing anything in an automated way. We're going to see it very soon. Then there are tools about data labeling, about training, about datasets, about doing prediction, about doing hybrid AI, about doing orchestration of pipelines, and obviously about doing deployment and doing deployments and continuous monitoring. So Vertex AI is having or is holding many tools and a lot of tools to help you as a machine learning engineer to have like a good experience with the MLOps and with the deployment step. So you can see that those are a lot of tools. And the question here is, what is the right tool for you? So we can start with a very simple question, which is, do you have your own training data? So here we can be divided into two steps. Is if no, then directly go to pre-trained APIs. I think all of you guys do know about pre-trained APIs. And if yes, then you are going to ask yourself another time, are you writing the model code yourself? Like, are you going to code a model? If yes, another thing. If no, then you can going to go to AutoML, directly to AutoML, because AutoML is allowing you to train edge models, cutting edge models into like without code and into a very small amount of time. So AutoML is here for this. Then if you are going to write your own code, then there is a service called custom model tooling, which is available on Vertex AI. So let's start with pre-trained APIs. Pre-trained APIs are being used when in the case where you do not have data, like you do not have your own data sets, and you want just like to use some pre-trained APIs. So here, GCP or Google Cloud Platform is offering you many tools like the Cloud Vision Intelligence for dealing with images and videos. We do have also the Cloud Natural Language API and Speech to Text API for dealing with text, speech to text, and NLP stuff. And we have the Cloud Translation API. So this is the case where you do not have any knowledge about machine learning and you do not have any datasets that are available for your case. So we just like use something pre-trained. And then here for the custom tasks, basically custom tasks mean creating your own dataset, creating your own model and training it, and then deploying it to a specific endpoint and getting prediction from that endpoint. Vertex AI also basically supports two modes: the UI-based mode, which is like on the console on the GCP platform website, and there is the coding or the programmatic model development, which is like also refers to the Vertex AI SDK. So using the SDK, we can code anything we want without the help of the UI-based model development. For datasets, now let's speak datasets a little bit. So Vertex AI offers you the choice of creating your own dataset in many formats, in image format, tabular format, text format, or also video format. For the image format, we do have two main, you have the choice of choosing two main types. The first type is the classification type. So here, if you have a dataset that you are going to classify into some specific classes, so you do upload it here. And also do you have the opposite. If you have object detection task, so you want to detect objects inside an image, here you can upload it also by your own. There is also the tabular datasets, which is like CSV files and Excel files, etc. So those are going to be helpful for regression and classification also. Then there is text datasets, which is going to be helpful into doing some tasks like text classification, sentiment analysis, named entity recognition, etc., etc. Then we have video datasets, which are like Vertex AI is like differentiating between images and videos, which is like not many platforms do this, because many platforms do like correspond the video to many frames, many images, so they are also images, which is true. But here Vertex AI is offering you the capability of uploading specific videos and applying machine learning and training your own model into videos, directly into videos, which is like something very great. Okay, so that was for the datasets. Now we can see a little bit about the models. So basically about datasets, we have two main parts. So we said if you do not have datasets, you can use pre-trained API. If you do have it, you can create it from the dataset service. Now that the question here is, are you willing to code the code by yourself? So here, if no, then basically you are going to choose AutoML, and if yes, you are going to go and choose your custom model. And what's the difference between AutoML and custom model is that in AutoML you do not take care about what's happening in the code and which model the machine is choosing. But in the opposite way, while building a custom model, you are going to be obliged to control your model architecture, which is like very good, because in all the cases you are going to need to build your custom model. AutoML is being like used in the cases when people do not know how to code models. So for non-coding teams, basically they can use AutoML, but for coding teams they do prefer to have control on their model and try to explain it and try to fine-tune the parameters by their own. So you can do this also in Vertex AI. So as we said, like in AutoML training, you just select the dataset and everything is going to be done for you. The model is going to be created, trained, evaluated, and deployed for you. Now, when the case you want to build your custom training, here you have a variety of choices. You can either like select a virtual machine where a notebook is going to, a Jupyter Lab is going to be deployed on it. You can also benefit from GPUs, from CPUs of the GCP, the Google Cloud Platform, like App Engine or but virtual machine service. So here you can, as you can see here, you can create a notebook in TensorFlow. You can also choose the framework, then choose the storage that is going to be connected to it, and tada, you are going to have your model uploaded and deployed. Now for deployment, you need to go and check like another service which is called Vertex Endpoints. Endpoints is just like an API. You can think about it just like an API. So an API where it's going to give you a specific IP, then you are going to send requests, post requests to that IP, and then expect some response, and then just communicate as communicating with an API. Also, it does offer you the capability of trying opening many notebooks. So basically, you can either like open notebooks in TensorFlow, in NumPy, CPy, Scikit-learn, in XGBoost, and only Python, and you install your own packages. So it does offer a variety of choices to do while dealing with your own notebooks. Yeah, it also contains a Git integration pre-trained or pre-integrated, which is like something very good because, as I said, the problem with machine learning is that like machine learning engineers are changing the code on the same notebook, and they are changing the parameters on the same notebook, so they do not keep track. Here with Git integration pre-done on the Vertex AI, you can like keep your code safe and keep track of your code. Okay, so basically in real world scenario, like you are going to be dealing with many with a big team and within an organization. So we are going to solve different machine learning problems, and as we said, Vertex AI with its solutions is going to be helpful. So we have seen the main solutions that everyone can be using, but if you are going to start over Vertex AI or learn Vertex AI only for MLOps, the services that are going to be helpful for you are feature store, continuous monitoring, metadata, experiments, and pipelines. Mostly pipelines is the very important one and the most usable one. And we are going to see it inshallah in the next session. But basically, MLOps or Vertex AI is going to be integrated and connected to your web application or mobile application or desktop application also, and it's going to take response from it, and like it's just like going to be a closed loop. So the loop is closed as an end on Vertex AI. Vertex AI is going to be taking care of monitoring your model, serving it, production it, and also retraining it and evaluate it and like give you better results. So basically, Vertex AI, if you configure it very well and you connect it to your like application, is going to be something very useful. So feature store, the very first like tool with us is just like a service that is going to store your features, your training features, and then update them all over the time when there is some change on the real world data coming from the live streaming, from the model, from the production model. So if the production model is expecting some features and then some other features showed up, feature store is going to take the opportunity to adapt the features of the training model into the new features, then retrain it and give you a new model applied to those features. So he's going to be able to detect it, which is something very also very good. Also, when reaching to deployments, basically we do not need to only stop in deployment. As I said, like we need to monitor the deployment, monitor the model on the deployment, and also monitor the data on the deployment. Because data, the model, as we said, like machine learning is data centric. Machine learning systems now are data centric; they are not model centric. So with Vertex AI, we are going to also give many importance to data, and it's going to be very helpful for the development and for the quality of our model. Then it comes the managed pipelines, which is like based on TFX and Kubeflow pipelines. It's the subject of the next session, inshallah. It's going to be about managed pipelines and basically about TFX and Kubeflow. And as a very big overview on those managed pipelines are going to help you to like define the steps that your data need to pass over in order to predict, or in order to train the model, then predict your results. So you define everything in a very big pipeline, then everything is going to be done for you with one click. So this is the advantage of managed pipelines. Yeah. Okay. So just a recap: the machine learning workflow is about like gathering data, making the model deployable, streaming the workflows like using pipelines with in your model, monitoring it, and retraining it, because new data is going to be coming from real world. So we do need to collect this data and give it to the model under time to retrain. So he's going to enhance his quality and be able to treat as many cases as we can, which is like what we are looking for by using MLOps. And by this, we have reached the end of our session. So, if anyone of you is interested about like knowing more about Vertex AI, here are some links that you can check. And if you have any questions, please type it in the chat. And basically, for the next session, inshallah, we are going to deep dive into MLOps with no managed tool. Like we can use Vertex AI, but the non-managed side. So we're going to try to discover Kubeflow and try to discover also TFX and do some application with it and some practice with it. So yeah, if any questions, you can type them in the chat. I will be happy to answer them. And in the meantime, we are going to have the links on the chat. Okay, so if no questions, I will say see you inshallah on the next session, and have a nice end of the day. Thank you.